I feel like I'm on a WebEx call. Can you hear me now? Put your headphones on. Seriously, is the mic okay? Is it a good spot? Yeah, no, you can't hear me? Okay, fantastic. Thank you. Hi, good afternoon, everyone. Thank you for joining me at the Cisco U Theater. My name is Patrick Gargano. I'm an instructor and a content developer with learning and certifications. Content developers, well, develop content. I'm part of a really big team that creates all of the official Cisco learning content that you'll find on Cisco U, or that you might have taken with a learning partner with like an in-person class maybe. My team develops the CCNA content, enterprise core, advanced routing. I'm responsible for the SD-WAN content, and so I thought I'd talk a little bit about SD-WAN this afternoon. We've got 30 minutes, so it's like, hang on to the train, we're about to go. I just want to at least give you a sense of the terminology so that you understand what we're talking about when we talk about SD-WAN. Towards the end, I'm just going to kind of shift gears and talk a bit more about where you can find some content in Cisco U to help kind of learn more about it if you're interested. Talk about the certification on SD-WAN as well if you're interested. And I know the real reason you're all here, at the end of the session, I'm going to be giving away 3 copies of the brand new 2nd edition SD-WAN Cisco Pressbook. I would really like the 3 copies, to go to a good home. What I mean by that is to someone who's actually going to use it, possibly to get ready for the certification exam. So what we'll do is those people, maybe after the session is done, we'll move over to the side and we'll do a draw just with you, if that makes sense for everyone, right? I would like it to go to someone who's actually going to not just like, oh, I got this and I never opened it, right? So thank you. Okay, here we go. Quick overview. Yeah, I just said all that. Back in the day, so if we look at our traditional WAN deployments 10, 15, 20 years ago, they looked a lot like this. Everything was coming through the HQ, the data center, before heading the internet. In other words, the HQ, the data center over here, was doing all of our security, all of our external connectivity to the internet, and all of our branch locations, our folks that were traveling, at Cisco Live, connecting back via VPN, for example, everything had to go through here for the security policies, for access to whatever servers might be available there. And then from there, hit the internet, hit those services that were publicly available. This was expensive. It was problematic on a bunch of different levels. We were leveraging primarily MPLS links in this case. It was the only thing really that was, you could get an SLA. It was predictable, but they were expensive, and sometimes they took quite a while to deploy in certain locations. And obviously, the other ones were using, just like I said, maybe an IPsec VPN across an internet connection, right? A normal internet connection. So this is what was traditionally our deployment back in the day. We're just kind of moving to another model now, right? And it's not like of today. We've been looking at this model for maybe 5, even maybe 10 years now, kind of moving from everything flowing through here, right? That kind of a hairpin thing going through the data center, to anyone kind of anywhere accessing whatever service they need. And more of those services were being hosted in the cloud. Now, I know over the last couple of years, there's been kind of a return to the on-prem, right? I don't know if you've come across that. We were so excited maybe 10 years ago about throwing everything into the cloud and leveraging the cloud. And then suddenly we start getting the bill and we're like, man, this is an expensive investment to have all of my services in AWS. Was this the right move? And then you looked at your on-prem and you're like, we had all the stuff that we needed to run this and we had already bought it. So a lot of people are moving back towards that. And a lot of people are doing like a hybrid thing, right? They're moving some stuff back on-prem, but still leveraging some things in the cloud. But anyways, at the end of the day, this is the kind of the model that we were kind of going towards over the last 5, 10 years. So it doesn't matter if I'm at the branch, if I'm roaming, or I'm at the data center. I need to access maybe all of these different services either directly to the internet or any kind of a SaaS application or an IaaS application, whatever I needed. So this is where I'm kind of moving towards. And the whole premise around SD-WAN was to kind of just help you move towards that possible deployment, especially to get access to all the cloud stuff up here. So if I'm thinking SD-WAN, I'm thinking anywhere. what I mean here is doesn't matter if I'm at the data center, doesn't matter if I'm at the branch location, remote worker. I'd like to be able to access that fabric from whatever location and access it, and even extend the fabric into the cloud as well. This is probably the big one. I think that the idea that we want to move away from just focusing on that MPLS link and using other things. Obviously, the big one that we would leverage would be this one. But and I love how people say, "Oh, SD-WAN, it's the end of MPLS." That's not right. That's not true. It's not the end of MPLS. We'll still use MPLS. We're just going to use some other things with MPLS and maybe use our MPLS a little bit more cleverly, a little bit more intelligently. But again, what we're doing is we're trying to use other transports that are now available that give me more flexibility in terms of easily deploying a branch location, whereas I would have had to wait months and months for that MPLS link to come up. Maybe I can get that branch location up very quickly with an internet link. And if you're like me, you're from Canada and you're like in northern Canada and it's very far away from anything, and the only WAN connection I can get is this, well, I can still bring up that branch location and leverage this until I get something else up. Does that make sense? So I'm just trying to offer myself some more possibilities of connectivity, which is what SD-WAN is all about. This one here, software-defined cloud interconnect. This is like Equinix and Megaport. It's just allowing me another type of middle mile connectivity between my locations. All right. So again, any kind of transport. Obviously, services. I need my security. Obviously, I need my voice. That's been around forever. So I need to make sure that whatever solution I'm about to deploy, in this case, an SD-WAN solution, it'll still carry all of the stuff that my current network is using, right? The voice, collaboration, all the security services. I'd like to be able to deploy this in a bunch of different ways. And I think this is what's kind of interesting about SD-WAN. You could have a full on-prem SD-WAN setup with all your controllers, and that's fine. I was talking to some military organizations. If I told you, I'd have to kill you. And what they do is it's completely isolated, right? Their own isolated SD-WAN fabric environment, not connected out to the internet. But in a lot of cases, we're going to maybe leverage the cloud to host our controllers, to simplify the management of all that, and still be able to deploy my branch locations. Obviously, I want it to be scalable. I want it to be programmable, and we'll be able to do that with automation through the platform. Really, really quick, just kind of a sense of what it's supposed to do. I'll go through this one as well fairly quickly. Just kind of hit on some of the features, if you like, of SD-WAN. First thing I just want to mention, I'm going to be showing you a bunch of topologies over the next few slides. And you're going to see these two icons. Well, actually, you're going to see this one a lot and not this one that much. This is the original SD-WAN icon for a WAN edge router. So just the router itself, that was the icon we would use. But the marketing team is moving towards a new icon. So if you download any of the SD-WAN content from the Cisco website, PDFs or whatever, you might see this little icon instead. So it's the same thing. It's just the WAN edge router that they're talking about. So listen, SD-WAN gives you a bunch of possibilities in terms of deploying your routers in those branch locations or on-prem or in the cloud. They can be a piece of real gear, like a real hardware router, a Catalyst 8000, for example, an ISR 4000 if you go back a little bit further. But you can also spin these up in the cloud and virtually in a VM. So Catalyst 8000V, CSR 1KV, right? So all that flexibility, hardware, software. Again, we talked a little bit about this. I want to be able to have the option maybe of on-prem, but most of the time it'll be done in the cloud. And the advantage, obviously, in the cloud is I can have some redundancy for my different controllers. This is probably a huge highlight here of SD-WAN. I'll go back to my example of Northern Canada. So I open a branch location in Northern Canada. I grab the router. I ship it out there. Someone over there at the office takes the router, plugs it into that internet connection that they've got there, and stands back, lets the router boot up. The router is going to call home, plug and play. It's going to authenticate itself to your organization. It's going to join the fabric. It's going to download its configuration. That's what I'm talking about, zero trust here. It's going to join the fabric and be able to get that branch location up and running very, very, very quickly. This is a thing that throws a lot of people when we start talking about SD-WAN, right? The SD, what the heck is the SD all about? Because there's SD access. There's a guy doing an SD access lab over there. SD is software defined, and the whole premise behind SD is that we're taking the device that we would have traditionally had, so our router, which would have had 3 planes, management plane, control plane, and data plane. We're going to blow that open. We're going to pull all these pieces out. We're going to have a management plane separate from the control plane, separate from the data plane. Now, obviously, the data plane is still going to have a bit of control plane, right? A bit of intelligence. But the idea is I want to split these open and apart so that my control plane can be centralized, easier to manage, right? If I have 1,000 routers and I need to configure OSPF traditionally, that's going to take me a little while across 1,000 routers. If I'm in an SD-WAN environment, I can log into the management plane, the management portal. It used to be called vManage. Now it's just Manager. And I could log into that, create a configuration for OSPF, push it to my 1,000 routers, and it's done. So I want to centralize that functionality and that control plane through SD-WAN. This is another one, right? What kind of topology is your enterprise using right now? And are you stuck with that when you're thinking, oh man, we've got like a weird, this is like partial mesh here, and over here it's full mesh, but we're stuck with this because we've had it for 10 years and I don't want to change it. The idea with SD-WAN is you can very, very quickly and easily change it to hub and spoke, partial mesh, full mesh, right? Again, centralizing the control plane, we're just sending that information to the controllers. They're going to push that to the routers and say, here you go, this is the new topology. I think I talked about this one already, right? Just some flexibility in terms of the types of transports that I want to be able to use. This one's not new either. I'm just going to use a different name for it. So you guys have heard about this a lot over the last 10, 15, 20 years, right? Separating, having different routing tables within the router, right? A VRF. We're going to do the same thing in SD-WAN. We're just going to call it a VPN. That's all. So if I have a branch location, what I can do is I can have multiple VPNs at that location. One for guests, one for employees, one for IoT. In a SD-WAN terminology, I would call those VPNs. I know you're thinking, hang on, what is he talking about VPN? It's not IP, it's not IPsec. We're just going to call it a VPN. Between you and me, it's just a VRF, right? We're just isolating those routing tables, right? Isolating the traffic from each one of these different services. It's another big highlight over here, right? So you as the network admin, you've got 500 branch location, 10,000 routers. You need something easy to manage all of that. We're going to do it from one place. As I said earlier, it used to be called vManage. Now we just call it SD-WAN Manager. And it's my single pane of glass. It's the portal I'm going to use to deploy, configure, troubleshoot, reconfigure, onboard new devices. I'm going to do it all from that place. Another cool couple of things that SD-WAN offers you, something called application-aware routing. So this is kind of clever. What it'll do is it's going to look at the different transports that the router has and figure out which transport is the best one for a specific application, or push a specific application down one transport. And then if that one fails, maybe send it to another transport instead. So it's aware of the application, aware of the performance of the application on a transport. And if that performance degrades, switch to another transport. More recently, though, in more recent versions of code, we've started introducing something called application quality of experience, right? So people are using cloud applications. You're not in control of the cloud. You're not even in control of the link between your data center and that application. You've got no control, but you need to monitor that all the way to the application so that if something goes sideways, you can use a different transport, maybe use a different path entirely to go hit a different data center somewhere else for that same application. Very, very clever stuff. Now, everyone's going to be like, yeah, how's this all happening securely? Well, yeah, we're going to use IPsec to create our tunnels between our different branch locations and the data center. So that's traditional IPsec, pretty straightforward, pretty safe. We're also going to use DTLS or TLS tunnels to push all of that configuration stuff that I was talking about earlier. So if I onboard a router and I need to push a config, I need to push a template to it to tell it how to behave, I'm going to do that through these DTLS tunnels. So everything is secure, it's authenticated, certificate-based, so it's safe. Last couple of things are the most, I guess, exciting highlights of SD-WAN, all of the cloud stuff that you can do with it, right? So a couple of things, right? I said already we were talking about applications in the cloud, so I mentioned quite a few here. We want to optimize that, right? My Microsoft 365, my Dropbox, my SAP. So I need to optimize connectivity to those different services. But I also might be hosting some routers in the cloud, right? Some VPCs. I need to optimize connectivity to those as well. And so I can do that through the SD-WAN environment. And just to come back to, right, I was talking about security here, but I mean, this is really the security. So there's a couple of options for security, and I've got some slides towards the end, and hopefully I'll have time to get to it. But the idea with the security is you've got on-prem or on-device security, features you can turn on like firewall, AMP, IPS, URL filtering. But there's a bunch of also extra security you can turn on in the cloud with like Umbrella SIG, so DNS filtering, secure internet gateway, all of these, CASB, all of these different services can be added in as well with SD-WAN. So there you go. You can talk about that tonight at dinner. So those are really the features, the very high level highlights of SD-WAN. All right, let's put it together a little bit for you here, okay? Again, if you started looking at some of the documentation around SD-WAN, you'll probably have come across this diagram a lot. It's been around for a while. I've updated it with the new icons, but at the end of the day, it's the same one. What I just want you to take away from it is the kind of split that you can see here. I mentioned 3 planes earlier. The data plane, that's where all the traffic forwarding is happening and my IPsec connections are happening between all my different locations. I've got my control plane, funny looking devices here. They're called very originally the controllers. Someone know what it used to be called? A V Smart. Thank you. Notice there's a few of these, right? We talked about redundancy. So if I have these in the cloud, I have a couple of these for redundancy. This is the brain of the operations. I mean, you're going to do all of your work from this thing, the manager, but this is really the brains of the SD-WAN, right? So you need some redundancy here. So I talked about those 3 planes. I've introduced a 4th one here. It's called the orchestration plane. Now, the idea with this one, it's all based around this device here, the validator. Used to be called the V-bond, thank you. This device, we call it orchestration in the sense that it's only involved when a router wants to join the fabric. It's like the gatekeeper to the SD-WAN environment. So if I spin up a new router, again, in Northern Canada, it's going to try to join the fabric. It's going to hit this device first for authentication. This is the one that's going to say, yes, you belong to me. You belong to this fabric. We're going to allow you in. We're going to push a config now to you. So this is like the first step or the first device that gets hit. Once it's authenticated, this guy stands aside and then everything else happens over here. I'll give you a quick run through of what's happening at each one of these, okay? So as I just finished saying, validator, not too complicated. It really is that first point of authentication. This is a virtual machine. It's running in the cloud. I mean, you could have it on-prem, but most of the time it's happening in the cloud. And like I said, this is the one that's going to then, once it's authenticated that router and said, okay, you can join this fabric, it's going to tell that router what the IP address is for vManage and the controllers as well. Sorry, for vManage, for manager, and for the controllers as well. The control plane, again, virtual machines happening in the cloud. This is the brains, really, okay? A lot of people think of it a little bit like a BGP route reflector, and I'll come back to that one in just a second when I talk about the routing protocol that SD-WAN uses. But at the end of the day, this is the device that will just have all of the smarts about how the routing is happening, how the topology is deployed, how the traffic is supposed to flow in and out of different locations. Is it supposed to go, right? Are we allowing direct connectivity from our data center to our branch, or does it have to go somewhere else first? Injecting maybe a firewall in the way, or intrusion prevention, intrusion detection. So this is really the brains of the operation. This is where we're gonna do all of our policies around SD-WAN. As I said earlier, this one is that single pane of glass. That's the GUI. It's just the GUI. That's where you're going to log in, sit down, and start creating your different configurations for your devices. So it doesn't matter if I'm deploying a new router in a faraway location, or my system, my fabric is already up, but I want to change the topology. I want to deploy VRRP somewhere. I want to deploy OSPF somewhere. So I'm going to do that all from vManage. We're going to push that to these guys, and these guys are going to tell these ones how to behave at that point. Going to use obviously REST and netconf to pull this off. Again, virtual machines happening usually in the cloud. And then finally, the last one is that data plane. So these are all the routers. Doesn't matter if the router is virtual. Doesn't matter if the router is physical. This is where we're going to leverage that zero-touch provisioning I was talking about earlier. This is where our IPsec tunnels are going to be built out. And it supports all of the traditional routing. So what I mean by that is, one of the things you're going to come across when you start looking at SD-WAN is, from the router's perspective, if we go that way, it's transport side, because those transports are this way. We go down this way, we're going to call that service side. That's where your IoT, your employees, your guests are, in those VRFs I was talking about. So we've got those guys at the bottom, down here. And that's all happening as well through the through this device. This is where we can turn on quality of service as well, right? Those things are going to happen at that place. So again, very brief, right? We only have half an hour here, but just to give you a sense of the names for all these things. How does this all come together? What's the magic sauce? It's called OMP, Overlay Management Protocol. This is the routing protocol. It's very similar, to be honest with you, to BGP, but it goes way beyond that. This is the protocol that's also going to carry, I mean, listen, not just how the network should operate, how the routing should operate. It's going to carry information about authentication, right, to allow these IPsec tunnels to be established. It's going to receive and transmit policy information to the devices. And it's going to carry 3 critical pieces of information. Actual IP prefixes, right, like OSPF, like EIGRP, whatever. We're going to call those OMP routes. Those are the prefixes, right? So if I had a little LAN down here, 10.1.1.0/24, and I advertise it into SD-WAN, call that an OMP route. I'll come back to TLOC on the next slide in just a second, but it's going to advertise those as well. And this is quite cool, service routes. What I can do with SD-WAN is I can have a centralized firewall at the data center, and I can inject that firewall into the fabric, advertising it as a service, forcing traffic from, let's say, this location to this location to travel through that firewall and back down again. So you can do that with a load balancer. Firewall is the typical one. Okay, I mentioned something called a TLOC, a transport locator. Now, what is that? Again, funny sounding thing. It's not too complicated. Let's simplify it as much as we can. 3 things are in a transport locator: who I am, what am I connected to, and what type of VPN or connectivity tunnel am I using? So who am I is a router ID. We're going to call it a system ID, but it's like a router ID in OSPF. So who am I? 1.1.1.1. That's my router ID. What am I connected to? What are my transports? Well, instead of calling it a transport, we're going to call it a color. And that can be, here we go. Right? It can actually be a color, gold and red and blue, but it can be internet, biz internet, public internet, MPLS, LTE, right? It's just the name that we're giving the transports that I have in my network. And then what type of tunnel or encapsulation? There's 2 flavors. The one you want to use and the one you don't want to use. IPsec would be the one you want to use, and GRE would be the one you don't typically want to use in this case. So a TLOC is a combination of those 3 things. So what are we going to do with those, and where are they? Well, when the router boots up, they're on the router. The router knows who it is. It knows what it's connected to and what kind of tunnel it needs to establish. What we're going to do with that is, as the router kind of joins the fabric, it's going to advertise those to the controllers. Right? It's like 1.1.1.1, hey, I'm over here, 2.2.2, right? It's going to advertise. They're all going to advertise themselves to the controller. And guess what's going to happen next? The controllers are going to then, by default, advertise all of this information to all the other routers. So now not only do I know who I am, I've advertised myself to all of you, and you're now doing the same with me. I know all of your router IDs. I know how you're connected to the fabric, and I know what kind of tunnel we need to establish. And then this is where things go nuts. Then at this point, by default, we're going to establish a full mesh of IPsec tunnels. It's okay if you have 4 locations, IPs in full mesh. Probably don't want full mesh in this case. Probably we would do a hub and spoke. I'd be the hub, you guys would be the spokes. So you would all advertise to me, and I would not then re-advertise out to you guys, right? And that would allow us to create that topology. That's, obviously this is by default the way it happens, but you can change that with the policy. That makes sense? Yeah, so TLOC, who I am, what are my connections? These are the transport colors here, whatever these are, MPLS, internet, and what kind of tunnels are we going to build? Okay, this is my favorite slide. We got time, cool. What I want to do with you guys is just kind of build one up. Let's build a very quick SD-WAN fabric together, right? We're going to power everything down, power everything back up again. Before we get going, let's just have a look at the diagram. So it's not too complicated. The smallest SD-WAN fabric in the world. I've got WAN Edge 1 over here. What's its name? 10.255.255.11. Okay. Apparently, there's another piece of critical information here, a site ID. It's just to know exactly what location it's in. It's just a number. We gave this one 10. Over here, we got 10.255.255.21. Got a location 20. Okay, fair enough. What else do we know? Well, it looks like we've got 2 transports. We've got internet transport and MPLS transport. I've got my controller up here. I think we're ready to go. What happens first? Well, first thing that's going to happen is we're going to establish secure DTLS tunnels with the controllers. That's the first thing that's going to happen. We need to have this authenticated and secure so that we can now start talking to each other. What's going to happen in these tunnels is we're going to start running our friendly OMP routing protocol. And this is the protocol that's going to carry the things I mentioned earlier, the prefixes, the T-locks, the services, all of the different control plane operations that the routers need. Okay, so we got that so far. What happens next? Well, we're going to start building these IPsec tunnels across these transports. Hopefully what you're noticing right away is there's no IPsec tunnel going up in here. This is just the brains. We don't want to see packets up here. The packets are going this way. This is just a conversation about how the packets should be flowing. Does that make sense? So this guy's going to tell them how to route and how to find their neighbors and all that. And then bang, we're going to create these IPsec tunnels this way. Inside these tunnels, we're going to run something called BFD. And that's going to be for each transport. Bidirectional forwarding protection. Little friendly protocol that allows you to monitor the quality of the link. This is really clever stuff. It's going to keep an eye on these links. And if ever, I don't know, what are we thinking here? This is, let's say this is our primary and this is our backup. So everything's flowing across here. BFD is going to keep an eye on this. And if ever this link goes a bit sideways, the quality degrades, let's stop using it and then start switching over here, right? Application aware routing, doing that kind of thing. Now, I talked about transport side earlier and service side. This is a really nice example. This is service side. What's going on here? Well, anything could be going on here. This is just a subnet. How did it learn about this subnet? Maybe it's directly connected. Maybe there's some OSPF down here. Maybe there's some RIP, EIGRP, doesn't matter. But we've got a subnet down here. And it looks like it's been assigned to VPN1. Okay. Same thing happened over here. I've got another subnet down here. So I don't know, 10.1.1.0, 10.2.2.0. And it's part of the same VPN. If they're part of the same VPN, will they be able to talk to each other? The answer is yes, unless you apply other policies. But if you put them in the same VPN, I should be able to ping. So if I have a server over here and a client here, I should be able to get to it. They're in the same VPN. And if I'm not done there, I can add another VPN as well. It's going to come up in a second. What else is happening with OMP? I mentioned OMP earlier, really, really critical. It's advertising the subnets, the T-locks. That's for reachability. It's advertising encryption keys for DTLS and IPsec. And then it's doing all of this really smart control and data plane stuff as well at the same time. So that's all being done with our OMP protocol. But like I said, what I just want to finish with here is I can then add another subnet, right? Maybe this was employee. This is guest. And so I've got the same thing here, employee and guest. Guests maybe can talk to each other, maybe not. Employees could definitely talk to each other, and that's fine. But I quite like this. It just kind of puts it all together, a bit like a puzzle of how the SD-WAN fabric comes together. How are we doing so far? Still with me? Okay. Last couple of slides before we wrap up. I just want to talk a little bit about cloud and cloud services, because that's a huge part of SD-WAN. So one of the things that you can deploy with SD-WAN is what we call cloud on-ramp for SaaS. It's basically just adding some intelligence, some smarts behind how you access your SaaS applications. Remember my first slide, everything was going through the data center and then going to the internet, maybe where your SaaS applications were. We don't want to do that, right? And not only do we not want to do that, but maybe our branch location has multiple transports, multiple connections to different service providers. Maybe one is a direct connection to an ISP. Maybe the other one is through MPLS to the other ISP. And so what I can do with SaaS or cloud on-ramp for SaaS is I can monitor, I can prefer this connection, right? I can say, this is my primary. But if something happens that I don't like, I want to fail over. I'm paying for this MPLS link, might as well use it. So if something happens here, I want to fail over, go through the regional hub because it's performing better and hit whatever app I have up here. So this is done again with cloud on-ramp for SaaS. And it's all about looking at metrics, right? Having a look at those BFD data, the BFD stats that I was talking about earlier to figure out which link is actually the best link. Probably this one is a big highlight as well. You guys are all using AWS. You're all using Microsoft Azure. You're all using GCP and others like that. We can integrate, we can extend the fabric. So what I mean by that is, again, you have 1,000 branch locations. You have this huge SD-WAN fabric for your enterprise. We can extend that fabric up into the cloud and spin up Catalyst 8KV routers, for example, in AWS, and add extra functionality in the cloud directly connected to my SD-WAN fabric. So I can also leverage things I mentioned earlier, like Megaport and Equinix. And again, this is all happening with these site-to-site IPsec tunnels for security, but it's all being managed by this guy. Last 2 slides are about security. I already gave you a hint about those ones. So there's 2 flavors of security for SD-WAN, on the box or in the cloud. So on the box, you get all of this. I mean, you have to pay for it, but you can turn all of these features on, right? So firewall, URL filtering, IPS, secure endpoint, used to be AMP, DNS, web layer security. So it doesn't matter if I've got guests at a location or employees who need access to the internet, access to different services. I want to be able to hit that way. Are we good? Okay, almost done here. Security for Umbrella. Cool. Okay. Last slides, I promise. You want to practice this. You want to get your hands dirty with SD-WAN. First thing you want to do is download CML. The new version of CML 2.7, 2.8 is going to release like any minute now, has support for SD-WAN built into CML. So please investigate that if you want to get your hands dirty and start kind of building your own SD-WAN fabric. I don't know if you guys are familiar with my colleague, Joe Clark. He posted a video on YouTube, I think it was last month, kind of going through all the steps you need to build your own little mini SD-WAN fabric in CML. So check that out. I can see that I'm missing a slide here. Yes, hang on a second. There's a slide that's hidden, but I really want to show it to you. This one here. Cisco U. Who's using Cisco U? Show of hands. Cisco U, Cisco U. That's where all our learning content is. So it doesn't matter if you're learning your CCNA, doesn't matter if you're working on collaboration security, any of the certs, or if you just wanted to know more about a certain technology, please check out Cisco U. If you have access to Cisco U, you got a full access pass, if you like, or a subscription, you can get access to. Basically what I did here, I searched for SD-WAN in Cisco U, and it just showed me all the different learning paths and courses and labs that I could do on SD-WAN. I've got SD-WAN fundamentals. I've got the certification aligned course, a cloud-based course as well. Loads of content that I've worked on for SD-WAN specifically, and it's all in Cisco U for you. How are we doing? Is that good? Okay, so I think, yeah. This is the last little thing. I'm going to do the draw here. And oh, actually, we have 2 draws. If you reach under your chair, someone will find this little guy kind of stuck and hanging underneath the chair. I can see it. It's underneath your chair. Give it a good pull. There we go. All right, we have a winner. That one is for just Cisco U pickleball set, right? So we'll give you that in just a second. First of all, thank you for joining me. A huge crowd. Really, really appreciate that you came out to listen to my very quick 30-minute chat on SD-WAN. If you have questions, I'm here all week. Find me and we can have a chat if you have questions about certifications or just about SD-WAN. But like I said, the thing I'd like to do next is for those of you that are really, really, really interested in the new version of the book, you just want to kind of get rid of your headphones, kind of join me on the side. We'll do a little draw just with that small group of people, and I'll be able to hand out that. Thanks for joining me, folks. Thank you very much.